Alright, circular motion quiz review number 3. So this one, you have a beach ball with a radius of 25 centimeters, and it's going to travel down a dune 20 meters. That's going to be our linear displacement, or delta x. As it rolls down, it experiences an angular acceleration of 32 radians per second squared. So angular acceleration is the fish, 32 radians per second squared. We're all good with units. Now, the parts of this question are asking for angular displacement while it's rolling down. How many revolutions does it go through while rolling down? Where is the fastest the object rotates, and when does this happen? When meaning physical location, not time, sorry. And then the last part of the question is asking how long it takes till it gets to the bottom. Now for the angular displacement and revolutions situation, you can do one of two things. The first option is to find angular displacement first and then revolutions. The second option is to do it the opposite. So if you want to find angular displacement first, the formula for that is angular displacement is equal to arc length divided by radius. In this case, the arc length is our total distance, and our total distance for our problem is going to be 20 meters. So we have our 20 meters divided by our radius of 0.25, which results in an 80 radian angular displacement. So arc length is just the length around the circle, but because it's rolling for a full 20, you can use that as your arc length. And then to find the number of revolutions, we know that one revolution is 2 pi radians. So if you have a total displacement of 80 radians and you divide that by 2 pi, that tells you exactly how many revolutions you experience. So 80 divided by 2 pi ultimately results in a 12.73 as a number of revolutions. Now, if the question asked for how many complete revolutions, the answer would be 12. Because it doesn't do 13 total. All right, now for the other option, option number 2 is to find revolutions first and then find angular displacement. So if you were to do that, the number of revolutions is equal to the total distance traveled divided by the circumference. Every time an object rolls, it rolls its own circumference. So you can figure out how many rolls it makes by taking the total distance of 20 divided by the circumference, which is 2 pi times 0.25. 2 pi r. So that gives you 12.73. So you get the same answer no matter what. So then from here, you can do 12.73 revolutions using the fact that angular displacement is the number of revolutions multiplied by 2 pi. You take 12.73, multiply it by 2 pi, and you will get 80 radians, just like you did when we went the first way. So the problem doesn't change no matter which way you do it. Totally up to you, whichever one makes more sense. So they both are correct. You can either do part A first and B, or part B first and A. It doesn't matter. All right, now the third part. What's the fastest the object rotates? Since the problem specifies rotate, that means you're looking for your angular speed. If it asks for the fastest the object traveled, that would be linear. Because when it's rotating, technically it doesn't have to be moving, because it can just be spinning in a stationary way. So this problem says what's the fastest the object rotates, and where does this happen? Well, in real life, if anything rolled down a hill or a dune, whatever, it's going to be traveling the fastest at the bottom. So we're looking for our final angular velocity. So we're going to use an equation. Omega final squared equals omega initial squared plus 2 alpha delta theta. Even though the problem doesn't say it, you can assume that it starts at rest because it doesn't specify. So we have all of the numbers to plug in. We get 0 squared plus 2 times 32 times 80 under the radical. Ultimately, that becomes 71.55 radians per second. And like we said, that happens at the bottom of the dune. So you're going to be moving the fastest you're moving at the bottom after you've rolled all the way down the hill. And the last part, how long does it take until the ball reaches the bottom of the dune? So the equation you use for this to find time is based on angular acceleration. So angular acceleration is equal to change in angular speed divided by time. Change in angular speed is omega final minus omega initial, and then you have your acceleration. So since omega initial was 0, you can do final, which is 71.55 minus 0, divided by acceleration, which is 32, to arrive at 2.24 seconds. So that equation might throw some of you off because you're like, where did that even come from? It came from this equation, which you already have. Omega final equals omega initial plus alpha times time, which you can rearrange to say omega final minus omega initial equals alpha time. Final minus initial is change, so change in omega is equal to alpha times time, which you can then rearrange to say that alpha is equal to change in omega divided by time. So all that put together is how you solve this problem. So it takes a little while to do, but you can do anything in any order, like we said. So you can do A, B, C, D. You can do B, A, C, D. Technically, you can't do C or D until you know the angular displacement. So really, you have to do A or B first. So your final answers for A is 80 radian, B is 12.73 revolutions, C is 71.55 radians per second, and D is 2.24 seconds for the whole thing.